Hello everyone, welcome back. I hope you guys were able to enjoy some of the nice weather that we're having this week or have had, depending on when you're watching these videos. We just wanted to say on behalf of Mrs. Gerzone, Mrs. Specht, and myself, Miss May, I just wanted to thank you guys for still tuning in and still working hard for us. We have 3 more weeks left of school. That is nothing. For those of you who have been working hard the whole time, we really are so proud of you. Continue it on. It shows a lot of character and with how hard you guys are working at home. So we are really proud. With that being said, today's notes are for Monday, May 18th. These are going to be the notes. I always just like to put that on the top. That way you guys can help me out when I'm grading or help whomever out when we're grading. All right, so today's lesson is going to be about explicit formulas. And we're going to focus on arithmetic. Okay, but I want to do a bit of review before we start, and then a little bit of a chart that you guys can use for this week to help you keep track of these different formulas. All right, the first vocab I want to review with you is, and I'll only do a couple of them. What does A1 mean? What does AN mean? And what does N mean? I may add a few more, but we'll talk throughout the lesson about those. I just want these to be in front of you. A1 means the first term in the sequence, first term. AN means any term in a sequence. And N means the number of the term, which I'll talk about a little bit more. We'll talk about that a little bit more. I don't think I want to add any more right now. Okay, so now I want you on your paper to make a bit of a chart. Okay, that was not a straight line. A little bit of a chart across. You're going to have 2 things going in there, 1 thing going in here, and then make a little bit of a line here, and we're going to, that's going to be our bigger sections. That is a horrible square. Hopefully yours are nicer. All right, so the 2 types of formulas that we've learned so far are arithmetic. That's when you add or subtract, okay, to get from one number to the next. And then the other type was geometric. And that's when you multiply, okay, to get from one number to the next in the sequence. Arithmetic formulas are linear functions. Geometric sequences are exponential functions, okay? So we're focusing on arithmetic today. So you're gonna see how arithmetic and linear really go together today. Let's review quickly before I teach you the new formula, the recursive formula. That was last week. So recursive formulas, you should know, but I wanna review in case it's been a week since you've seen it. This is when you can find one number at a time. So we use recursive formulas when you want to find one number at a time. And let me just show you, you don't have to write this down, but from your notes last week, this was a recursive formula right over here. And we used that to find one number at a time. You needed the number before it, so you could plug it in to find the next number. Then you'd use that number to find the next. You couldn't just jump and find the 100th number. Okay, today's formulas, you're going to actually be able to do that. So, recursive formula for arithmetic, you needed your A1, and then A of n equals your A sub n minus 1. I want you to make sure that's nice and small, plus your common difference. That's what you add or subtract by. And then for geometric, it was you still needed your first term, A1 equals, and then A of n equals your common ratio was being multiplied by A sub n minus 1, which was the previous number. Remember that term, okay? The types of formulas you're going to learn today are explicit. And I'm only going to show you the arithmetic one. We're leaving this blank and you can fill this in on Wednesday. So the explicit formula, this helps you find any number in a sequence. So this one helped you find one number at a time. This is any number. I could find the 1,000th, millionth number. It's not a number, but I could find the 100th number if I wanted to by just plugging it in. So the explicit formula looks like this, and you just need to memorize this. It's a of n, any number in the sequence, is equal to your first number, your a1, plus, in parentheses, it's a big N minus 1, so it's not a subscript like that. It's not showing you like the previous number. That's just the number that you want in the sequence, minus 1, times your common difference, and we write it out back like this, and then eventually you would distribute it in, which you'll see in a second, but this is being multiplied to your N minus 1, okay? So I want to point out a couple comparisons here. You still need your first number in the sequence, okay? I still need my A1 to write it, and I still need my D, and those are the common difference. Those are the only two things I need in order to write an explicit arithmetic formula, is your A1 and your D, okay? So similar to your recursive, where you need to find those first, and then I'll show you it's a little bit more involved with this one because you usually clean this up a little bit. We're leaving this blank for now. We're gonna go right into our example. Okay, so for the sequence, I told you we're just doing arithmetic today, so it's just gonna be adding or subtracting sequences. So we're gonna do a couple examples and then I'll give you follow-up questions. The first example is gonna be the sequence 10, 17, 24, 31, 38, and 45, okay? And the instructions are gonna be write an explicit formula for the sequence. Okay, so again, explicit formula, we're gonna look here. You need your A1 and you need your common difference, okay? So I'm just gonna write those over here. My first term in the sequence is 10. My common difference, well, let's see. What do I add or subtract by to get from one number to the next? And I know it's adding or subtracting because it's arithmetic. So plus 7, does that work throughout? You should always check plus 7, plus 7, plus 7, plus 7. Yes. Okay, so my common difference is 7. All right, so I'm using this formula and plugging these numbers in. Let's write the formula out because it's always good practice when we learn something. A of n equals A1 plus parentheses n minus 1, close parentheses, times D. Okay? And now I'm just going to go ahead and plug in my A1 in for A1 and my common difference of 7 in for my D. All right. So A of n, any number in the sequence, is equal to 10. That's what I plugged in, 10 for A1, plus the n minus 1 drops, and I'm plugging in 7 for D. You can plug it in like this. You can also put it in parentheses so that you know you're multiplying. Either or works for this one, okay? Now, this is an explicit formula, but we usually like to clean it up, and we're going to do that, okay? So what I mean by that is I'm going to distribute the 7 in to these parentheses. So it's going to be A of n equals 10 plus 7n minus 7. Okay, and then when you have like terms, you always want to combine those. So I can combine 10 with negative 7 right there, and I am left with A of n equals 7n plus 3. That is my explicit formula, okay? And like I said before, this is an explicit formula. It's the same one as that. This is an explicit formula, same one as that. And so is this. It's just this one's the most cleaned up version is how I say it, okay? All right, a couple things I want to note here. I want you guys to see. The 7 next to the n, notice that that's the same number as your common difference. That is not a coincidence. Anytime I put my common difference in here and I distribute it in, it's always going to find its way next to the variable n when you clean it up in an explicit formula. So you need to recognize that the number that's next to n, if you were ever to see a formula like this, that is your common difference. So underline that and write a note to yourself. And the note is going to say the common difference will always be next to, I'm going to say next to n. Okay? The other thing I want you to see with this formula is that this looks like what kind of function? Well, I hope you guys recognize. It looks like your y equals mx plus b. It looks like a linear. Okay, where it would have, in this case, your y-intercept would be 3, and you'd go up 7 over 1 if you were graphing something like this, okay? But this is representing our sequence. And now I'm going to test it out, okay? I told you guys that this formula, you can find any number in the sequence. So what I mean by any number, if I'm looking at this sequence, well, this would be your A1. 17 is your A2. 24 is your A3. Your fourth number, A4, would be 34. Your fifth number in the sequence, A5, would be 38, and your sixth number in the sequence would be 45, okay? So if I wanted to find, let's say I said, okay, use formula to find the sixth number in the sequence. Well, I already know it's 45, but I'm proving to you that this works, okay? So I'm going to take this formula, AN equals 7n plus 3. Now I'm finding the sixth term of the sequence, so I'm going to write A6, that's the sixth term, equals 7 times, okay, there was an n up here that I made into a 6. That means this n right here is going to turn into a 6 as well. That's what my n is equal to right now. So times 6 plus 3. A of 6, or the sixth term in the sequence, is equal to, that 7 times 6 is 42. 42 plus 3 is 45. And the way you would read that, you'd say the sixth term in the sequence is 45. Do we know that's true? Yes, we do. Okay? So that's how this formula works. I can plug any number in. I could plug 100 in here. I could plug 200, 300, 400, and find the 400th number in the sequence without having to find each number. That would take forever, right? So that's why these are nice, these explicit formulas, okay? I'm going to do one more example, and then I'll send you on your way. Okay, so this will be example 2. And the sequence for this one is going to be 4, 1, -2, -5, -8, ... Okay, and you're going to write the explicit, and I'm just going to abbreviate this, write explicit formula. Okay, so first thing you're going to figure out here, and since this whole lesson is arithmetic, you should not really have to do much thinking here, is that these numbers are going down through subtraction, and we're subtracting 3. So it's arithmetic. Okay, my first term, my A1, is 4, and my common difference, what am I going up or down by, is -3. Okay? So now, rewrite your formula. Any number in the sequence is equal to your A1 plus parentheses n minus 1 times your common difference. A of n equals, my first term is 4, so this is where I'm going to show you through highlighting what goes where. 4 plus n minus 1 times my common difference goes at the end. Now be really careful here. Let me show you what happens when I plug the -3 in here. Okay, that no longer looks like it's multiplying, right? My common difference is supposed to multiply itself into these parentheses. If I have a -3 sitting there, it no longer looks like it's multiplying. It looks like subtraction. So in this case, I have to put parentheses. Okay, up here I said you didn't have to because you should know that that means multiplying. You can, but in this case, when there's a negative, you do have to, because then it just no longer looks like multiplication. All right, from here, you're gonna clean this up or distribute in our -3. So you're gonna have A of n equals 4 plus -3 n plus 3, right? -3 times n, -3n. -3 times -1 is +3. Let's clean up and combine like terms here. A of n equals -3n plus 7. Okay. Note again that my common difference of -3 you see right here next to the variable n. Okay, that's not a coincidence. You'll always see it there. If you ever were just to see this, equation and they said, what's the common difference? You should know it's -3 just by looking at it, okay? All right. So now I'm going to prove to you why this is so nice to have explicit formulas. If I asked you to find the 100th number in the sequence, and you didn't have this formula, you would have to subtract 3 100 times. That would be a real giant pain. But now that I have this formula, I'm going to rewrite it, -3n plus 7. To find the 100th term, it would be a of 100 equals -3 times 100 plus 7. Okay, remember when I changed my n to 100, I also plug that in for n on the right side there too. Okay, a of 100 is equal to -3 times 100 is -300 plus 7. And then, of course, you can combine those like terms or plug that in your calculator. A of 100 is equal to -293. And that's helpful to know because so that way I don't have to do it in my calculator, okay? All right. So, your follow-up questions on the back. Follow-up questions for 518. If you date it, that makes it helpful for us. Okay, for these, I'm going to give you 3 questions. Question 1, and for all of them, I want you just writing the explicit formula and then finding a certain term that I give you, okay? So here's question 1. Write the explicit formula for this sequence 1, 11, 21, 31, 41, 51, ... So you're going to write that formula. I'm going to give you some space here. So we'll say that's part A. And part B is to use the formula to find, I'm going to say the 9th term here. Okay? On the other side, we did the 6th term, I think, and the 100th term. So this one, 9th term. And I'll give you some room for that. Question 2, you're going to write explicit again for this sequence. 18, 10, 2, -6, -14. And you can write the formula here if you want. And then B, use the formula to find, I'm going to give you the 100th number. That way I know you did it right and didn't just, times by 9 up there. Okay. And then question 3 is going to be a simple one. What is the common difference given this explicit formula? And the formula is going to be a of n equals 3n minus 7. Write your answer there. Your common difference equals. And I'm going to give you another one just because, why the heck not? 4 plus 2n. Write your common difference there, okay? All right, guys, feel free to go back and watch over anything you didn't understand or pause if I was going too fast or if you need to take any more notes. And I will look forward to seeing all your work on, well, I guess by Sunday next week, okay? Have a great rest of your week, and I'll see you soon.